Section 7.2, example 5, finding the solution to a dependent system of equations. So find the solution to the given system of equations in 3 variable. So let's see. I like these two. Oh, I like these two right here so far. What I really want to do is add these two together. What we have to, let's eliminate the x's. Let's multiply this one by -2. So that way when we added the x's, eliminate. So -2 times equation 1 are 2x plus y minus 3z is equal to 0 times -2. And we have -2 times 2 is a -4x. -2 times y, -2y, -2 times -3, positive 6z is equal to, well, 0. All right, so that's equation 1. So now we're going to add equation 1, or our modified equation 1 with equation 2. Let's do that over here. So we have -4x minus 2y plus 6z. That's the equation we just found. Let's add equation 2 to that. 4x plus 2y minus 6z equals 0. Add these two together. All right, our x's are eliminated. Our y's are eliminated. Our z's are eliminated. All right, so on that left side, we have 0 is equal to, see what we get on this side. 0 plus 0 is 0. We have 0 equals 0, which tells us we have infinitely many solutions. Infinitely many solutions. So because we have infinitely many solutions, we have to write everything in a way that shows what all the different possibilities are. So since equation 1 and equation 2 are technically exactly the same, we're going to use equation 1 just because it has like less multiples. We're going to use equation 1 and see what we could eliminate here for equation 3. We still have to technically see where the other stuff lands. So let's use equation 1 and equation 3. If we were to add those together right off the back, our y's were to eliminate, and then we have the other variables there. So we have 2x. So let's start with equation 1. Then equation 3, 2x plus y minus 3z equals 0. And equation 3, x minus y plus z equals 0. All right, so adding those two equations together, 2 plus 1 is 3x. Our y's are eliminated. And z is going to be -2z. 0 plus 0 is 0. And there we go. So y ends up being eliminated. We could put everything in terms of y. So x, in this case, let's solve for x and see what we have there. All right, let's make everything in terms of x instead. So here we could solve for z. Let's solve for z in this equation. So we have 3x minus 2z equals 0. 2z is equal to 3x. We have z is equal to 3 over 2x. So we'll let x equal x, and we'll let z equal, z equal 3 over 2x. So far we have x and we have z. Let's figure out what y is. So that's our z, figuring out y. We could use any one of these equations. Let's use this last one just to see what we have. So x minus y plus z equals 0. All right, so we found out that x is just going to be x. We're going to solve for y. We just found out that z is 3 over 2x. So now let's solve for y. So x, we could say that this is like 1 over 1, or 2 over 2x plus 3 over 2x minus y equals 0. Let's add y to both sides just to move it over. But at the same time, let's add those two together. That gives us 5 over 2x is equal to y. There we go. So we said that x is going to be equal to x. X is going to be equal to x. Y, we just found out, was going to be 5 over 2x. And z is going to be 3 over 2x. All of these are in terms of x, which makes it even better. So there we go. If you have any questions, please feel free to ask. Otherwise, bye.